From the exact moment your alarm clock blares in the morning, your entire day is basically powered by chemistry. You just might not realize it. So in this Explain, we're going to pull back the curtain and uncover the hidden science behind your morning routine, starting with that very first step into the shower. Really think about that for a second. Is your shower a chemistry lab? Well, the answer is a big, resounding yes. That simple act of getting clean, it's pretty much a masterclass in chemical reactions. And today, we're going to break down exactly how it all works. So our chemical journey starts with something super simple, a bar of soap. But have you ever stopped to wonder what that bar is actually made of? The origin story might just surprise you. It all starts with really basic stuff, like animal fats and vegetable oils. And the transformation from, grease to a clean bar of soap, it happens through a process called saponification. This is the absolute core chemical reaction that turns those fats and oils into the soap you use every single day. Just think about that. This ancient chemical trick is still the foundation of the soap sitting in your shower right now. Okay, so now we know how soap is made, but how does it actually work? How does it manage to get all that grease and grime off your skin when plain old water just can't get the job done? The secret, it turns out, is hidden in the very structure of a single soap molecule. It's kind of wild, but every single soap molecule has, a dual personality. It's this tiny little chemical agent with two very, very different sides. And this split personality is the secret to its incredible cleaning power. And this right here breaks down that dual personality perfectly. On one side, you've got the hydrophobic tail. It literally means water-fearing. This part hates water, but it absolutely loves to grab onto oils and grease. Then you've got the hydrophilic head, which is water-loving. So you've got one part of the molecule holding onto the dirt and the other part holding onto the water that's going to wash it all away. And this is where the magic really happens. Look at step 2. The greasy tails burrow their way into the oily dirt, completely surrounding it and trapping it. Then all the water-loving heads face outward, creating this perfect little package called a micelle. It's like a molecular taxi for grease. So when you finally rinse, the water grabs onto all those outer heads and poof, it whisks the entire grease-filled package right down the drain. And hey, here's a fun fact for you. The quality of a soap is often measured by something called its total fatty matter, or TFM. And to be considered a top-tier, grade 1 soap, it has to have at least 76% TFM. So something to look for the next time you're out shopping. But even the best soap in the world runs into a big problem. Something a lot of us have at home, hard water. You know that scummy residue you sometimes see on your shower door? The minerals in hard water react with soap to create that stuff. So, to solve this problem, chemists invented a superior successor, synthetic detergents. This chart lays out the key differences perfectly. You can see soap comes from natural sources, while detergents are usually made from petroleum-based chemicals. But the real game changer is right there at the bottom. Detergents actually work in hard water. That single advantage is why they've completely taken over our laundry rooms and dishwashers. Now, detergents aren't a one-size-fits-all kind of thing either. They come in 3 main flavors: anionic, cationic, and non-ionic, and each one has a different job. For example, anionic detergents like the sodium lauryl sulfate you see on shampoo bottles are amazing at creating that rich, foamy lather that lifts away dirt and oil. All right, so we're clean and we're out of the shower. Let's head over to the kitchen for that morning cup of coffee or tea. Now, if you're the type to skip the sugar, you might just be reaching for another fascinating piece of everyday chemistry. Yep, we're talking about artificial sweeteners. These are totally synthetic compounds that are designed in a lab with one single goal: to trick our taste buds into thinking we're tasting something sweet, but without delivering any of the calories that normally come along for the ride. And you definitely know these names, even if you don't think about the chemistry behind them. Saccharin, aspartame, sucralose, you've seen them, right? The little pink, blue, and yellow packets at every single coffee shop. Each one is a slightly different molecule engineered in a lab to give us that sweet taste without the sugar. So we're clean, we're caffeinated. What's next? Well, the chemistry show is not over yet. As we get ready to face the day, we are surrounded by even more clever chemical applications. The chemistry is just everywhere in these final steps. Remember glycerol, that byproduct from making soap? Well, it gets repurposed and used in cosmetics. And that isopropyl alcohol a nurse uses to clean your skin before giving you a shot? Pure chemistry. Even some eye lotions use a special form of silver called silversol.
It just goes to show you how these compounds are woven into every part of our day.
But maybe the most surprising example is hiding in an object you probably don't give a second thought to. A specific type of polymer called bakelite. It's used to make super common items like the simple combs and pens you see here. So that simple comb you use every day, it is so much more than just a piece of plastic. It's actually a complex, cross-linked polymer. And that just means its molecules are linked together in this incredibly strong grid-like structure, which makes it super durable yet lightweight. It's a tiny piece of brilliant chemical engineering just sitting there on your bathroom counter. So there you have it. We've gone from the saponification happening in your soap bar, to the little micelles washing away dirt, to the synthetic sweeteners in your coffee, and all the way to the very polymers that make up your comb. Your morning isn't just a routine. It's a full-on symphony of chemistry.
And that really brings us to our final thought. Now that you've seen the science hiding in your morning, the real question is, what other hidden chemistry is shaping the rest of your day? So my challenge to you is to keep an eye out. I promise you'll be amazed at what you find.